So my function will be, as we know, my f of x will be a0 plus summation n equal to 1 to infinity an cos nx. Let's find a0 and an. I start with a0. So a0 formula is 1 by pi 0 to pi f of x dx. So now 1 by pi 0 to pi and 0 to pi, my function is 1 minus 2x by pi. So I can say here 1 minus 2x by pi, this integrates for dx, so which I can write as 1 upon pi x minus 2x square divided by 2 pi, where upper limit is pi, lower limit is 0. So now this finally comes to be, that is nothing but 1 by pi, 2 and 2 gets cancelled. When you put pi here, pi minus pi square by pi, which gives me pi minus pi, which finally comes to be 0. In the same way, when you find an, so an is nothing but 2 by pi 0 to pi f of x multiplies to cos nx dx. So you can say 2 by pi 0 to pi, f of x from 0 to pi is nothing but 1 minus 2x by pi. This multiplies with cos nx dx. So here we'll be working as u into v. Let's apply u into v. So I get an equal to 2 by pi, then 1 minus 2x by pi, then integration of cos is sin nx divided by n, then minus differentiation of this will be minus 2 by pi, again integration minus cos nx divided by n square. So where your upper limit is pi, lower limit is 0. Let's put upper limit and lower limit. We have 2 by pi outside, and then when you put upper limit pi here, so that becomes here pi and pi cancel, 1 minus 2, sin n pi is 0, so don't need to take care of this. So first term is 0 here, then minus 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 gives me what, minus 2 by pi. Let's mention this. So first I get minus 2 by pi, and then cos n pi is minus 1 raised to n divided by n square. So I say I got minus 1 raised to n divided by n square. That's my first term. When I put lower term as 0, so first I get sin 0 as 0, and then minus minus minus, again I get 1 minus 2 by pi, and cos 0 is 1, so I get 1 by n square, so minus 2 by pi n square. So I say here minus 2 by pi 1 by n square, so which finally I get as nothing but, we can take 2 by pi common, which becomes at 4 by pi square, and here I can also take n square common, then this is nothing but plus 1, and here minus 1 raised to n. So this I got as my an. So I can say finally, let's substitute in series. So my f of x is equal to, let's substitute in series. My series was f of x a0. a0 is nothing but, so a0 came to be 0, so directly we need to put an here. So I can say here summation 4 divided by pi square n square 1 minus 1 raised to n, where your n changes from 1 to infinity. So we can say here 4 by pi square summation n equal to 1 to infinity 1 minus 1 raised to n whole divided by n square. So we know that, I just mentioned here, this term will be 0 if you say your n is even and odd. So this whole term you can say as, this will be 8 divided by, I mentioned whole term because here it will be coming as 2, 4, 8 divided by n square pi square. So I say my f of x is nothing but 1 minus 2x by pi. So now when I substitute here, and for deduction I'll be substituting, put x equal to 0. This gives me pi square by 8 equal to 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus dot dot dot. So this is finally which you can say that you got your final answer.